Okay, so we are learning the conclusions for this problem. So we'll just go through the problem once. So they're asking us to calculate the coefficient of correlation, and they've given us cost as well as sales, right? So they've given us cost and sales. So let us assume cost to be X and sales to be Y. So this is what we are assuming. Then we are going to copy down all of these values for X as well as Y. And this problem is where we are going to take assumed mean. Okay, so in this assumed mean, we have considered 65 as assumed mean and here 58 as assumed mean. Okay, so once we have considered this 65 and 58, we calculate dx, that is deviation, x minus assumed mean. So we get all the deviations and the total here has come to 0. Then again for dy, that is the deviations for y minus a, that is assumed mean. So you get the total as 80. Next, you are supposed to square the deviations. So dx square, and when you square all of these values, you get the total of 5389. Similarly, if you square the deviations from y, you get the total value of 2864. And then you're expected to multiply dx into dy. Here be careful with the signs, okay, because few places if you have sign for only one, minus sign for only one, you'll get a minus value. So dx into dy. So we have got all the major 5 totals here. Now let us go on and put that into the formula. Write the formula in every problem. N into sigma dx dy minus sigma dx into sigma dy whole divided by square root of n into sigma dx square minus dx sigma dx whole square, and then n into sigma dy square minus dy the whole square. Now we know what are the totals that are required to us. So n is 10. The number of data that we have is equal to 10. Then 2704 is sigma dx dy minus 0 into 80. Okay, many of them might got confused here. 0 into any number is 0. Okay, don't take the number. This is wrong. 0 into any number is 0. Okay, so divided by, again 0 square is 0. 0 minus any number will be the number, or 0 plus any number will be the number. But when it comes to multiplication, 0 into any number will be 0. Fine. So 27040 divided by square root of 53890 and 22240. Then take the square root of these two numbers. You will get correlation coefficient as 0.7810. Okay. Now let us draw the timeline. So timeline is the best way to understand the conclusion. So to first draw the timeline, just draw a line like this, assuming the right hand side to be plus 1. Okay, assuming right hand side to be plus 1, left hand side to be minus 1, and the value in the center will be 0. Okay, so this is the timeline which we require. Now apart from these values, there are 2 more values which you should always mark on the timeline. You can draw this timeline even in the examination and then write the conclusion. No problem. You will get marks. It's even better because they know you have analyzed it properly. Okay. Now the other 2 points are 0.25 and 0.75. Again, 0. This is minus 0.25 minus 0.75. Okay, so what are the points that we want? We want minus 1, minus 0.75, minus 0.25. I'm doing it from this side. Then we will have 0, then 0.25, that is plus, then 0.75, and then you will have +1. Okay, so these are the important markings that you are supposed to do on a timeline. Okay, now once you draw the timeline, check the answer, that is your R. So what is the value of R? 0.7810. Now 0.7810 is a positive number, correct? So if it is a positive number, it will lie between this only, because positive number is between 0 and +1. It is a positive correlation. As soon as you see the answer in a positive number, you should be able to understand it is a positive correlation. Okay. Now, after getting positive correlation, now let us go a little deeper and understand how to analyze. Okay. Now, next thing is 0.7810. Now, where can I place this 0.7810? Check that. We have benchmarks here starting from 0, then you have 0.25, then you have 0.75. Now 0.78, can I place it somewhere after 0.75? You need not find the accurate value, assuming it to be. Now if you see the value only, you will be able to understand it will come after 0.75, which is 0.78. Okay, any doubts until here? Did you all understand until here? Yes? I want everyone to reply. Okay. Now, in the timeline, what you have to understand, most important one is from where to where it is called high, low, moderate. Okay, so that is important to understand. Now let us understand that. From 0.75 to 0.75 to 1. I'll erase this also. Okay, so from 0.75 to 1, any values that you get between this, it is called as high degree. Okay, above 0.75, 0.78, 0.80, 0.96, 0.98, 1, everything is, if you get 1, it is a perfect, but from 0.75 to +1, it is high degree positive correlation. This is positive number, so positive correlation. Understood? Everybody understood the first part, how to know positive, high degree positive correlation? Now, if you see the answer here, it is 0.7810, which lies after 0.75. So this has a high degree positive correlation. That is all you have to do the analysis. Okay. Now this was high. Now let us understand the next benchmark. If the value is between 0.25 to 0.75, okay, 0.25 to 0.75, 0.25 to 0.75. This is moderate degree of positive correlation. Okay, this is going to be moderate. It is in the center, right? Between 0 and 1, it's in the center part of the values. So it is a moderate degree of positive correlation. Understood? Understood moderate and high? Okay. Now, let us see the next part. The next part is nothing but low degree of correlation from 0 to 0.25. From 0 to 0.25 is the low degree positive correlation. Be careful, it is positive. Okay, so this is low degree positive correlation. If you get points something like 0.15, 0.07, 0.20, all these are low degree positive correlation. It is positive number, so positive correlation. That's all. Understood? Understood the positive side? The benchmarks are 0, 0.25, 0.75 and lastly 1. So 0 to 0.25 is low degree positive correlation. 0.25 to 0.75 is moderate degree of positive correlation. 0.75 till 1 is the high degree positive correlation. Okay, so this is your first side, that is your positive side. Now let us go on to the negative side of the correlation. Now on to the negative side also, it remains the same mechanism. There is no changes much. Okay. Now from -1 to -0.75, okay, -1 to -0.75, high degree negative correlation. Okay, high degree negative correlation. Why negative? The numbers are in negative, they are in minus. So high degree negative correlation. Then from 0.75 -0.75 to -0.25 is moderate degree negative correlation. What is moderate degree? It is in the center. So -0.75 to -0.25. Okay, suppose this answer, if you had got it as -0.7810, then it would have come somewhere here. Then your answer will become high degree negative correlation between cost and sales. That's all. That is the only difference you have. Negative correlation, positive correlation. But where you have to take high value, where it is the moderate, where it is the low value, you should be able to analyze it. Okay. So from -0.75 to -0.25 is moderate degree negative correlation. And finally, from 0.25 to 0, okay, -0.25 to 0 is low degree negative correlation. This is low degree negative correlation if the value is between -0.25 and 0. So if you see the number, you will be able to analyze if it is a positive number or a negative number. So which means you will be able to say if it is a positive correlation or a negative correlation. Okay. After that, see the value. If the value is more than 0.75, it is high degree. If it is between 0.25 and 0.75, it is moderate degree. If it is less than 0.25 but until 0, it will be low degree positive negative correlation. Did you all understand now how to find the conclusion? Everybody understood? Anybody still has doubt? So did you understand how we got high degree positive correlation here? 0.7810 is a positive number, so positive correlation. And 0.78 is more than 0.75, so it is a high degree. So high degree positive correlation. Can we go for the next question? Okay. Now moving on to the next question. From the data given in the following table, find the correlation coefficient between age and playing habits of students. So, what are the main two criteria they have asked us here? Is the age. Age will become one criteria, and the other criteria is playing habits of students. So there are two criteria. But if you see the problem, there are three rows which are given to us with many columns. So let us go through the table. Age, this is criteria number 1. So we are going to take this age as X. But if you see, number of students and regular players are given to us. But what is the other criteria? Playing habits of students. So we have to do a little calculation here so that we will be able to get the required data to solve the problem. Okay. So this is the complete question. They have asked us to find correlation coefficient between the age and the playing habits of the students. Clear? Understood the question? Did you all understand the question? So, yeah, okay. Once again, we will see. Now, this question, they're asking us to find correlation coefficient between two data. Usually, what do we have? We have X and Y, correct? Here, they have asked, they've given the X as well as Y. But Y is not defined clearly. Y is not defined clearly. So we have to do a little calculations to define Y very clearly so that we will be able to calculate R for this problem. Okay, so let us go through this. Here we are asked to calculate correlation coefficient between age and playing habits of students. But we are given age, number of students and regular players. Okay, so out of these three data given to us, we are going to consider age as X. Okay, age is one factor, that is X. And from the other two data, that is number of students and regular players, we are going to do some calculation to find and define the values of Y for this X. So X is a independent factor and Y is a dependent factor. So we have to compute the rate of players out of the total number of students to relate it with the age. The rate can be taken as Y variable. So first, out of so many students, what they're saying, out of 250 students, 200 students are regular players. So let us find some ratio or percentage so that we will be able to arrive at a proper data for Y. Okay, so the formula to find the ratio here is ratio of regular players to the total students. Regular players, they've given us 200, 150, 90, 48, 30 and 12, and number of students, total number of students is also given to us. Okay, so at the age of 15, okay, at the age of 15, we had 200 regular players and the total number of players at the age of 15 were 250 into 100. So if I multiply it into 100, I get a percentage. So 80% of the students are in the age of 15. Next, at the age of 16, okay, at the age of 16, out of 200 students, 150 are regular players. So out of 200 students, 150 are regular players. If I calculate the percentage, I get 75% of them belongs to the age 16. Are you all able to follow? Yes, everybody is able to follow? Okay. Next, at the age of 17, out of total 150 students, regular players were 90. So 90 divided by 150 into 100. So 60% of people belong to the age of 17. Similarly, for 18 years, totally 120 students were there. Out of that, only 48 people are regular players. So 48 by 129 into 100 will give me 40%. And for age 19, out of total 100, 30 are regular players. So I get 30%. And for lastly, for the age of 20, out of total 80 students, 12 are regular players. So only 15% of them are regular players. Okay. So these percentages which we found here, these are the values of y which we will be considering to solve the problem. Okay, x is nothing but age in years and y are these ratios. Now, correlation coefficient between age x and percentage of regular players. Understand, percentage of regular players is y is computed. So we are taking that particular values. So everybody understood how to solve this problem? This is only first part of the problem. Yes, can we go to the table calculation now? Okay. Now if you see here, in the table calculation, we have taken x, that is nothing but age. Okay, that's nothing but age. Age is considered here. Next, for y, we have taken the percentages. 80, 75, 60, 40, 30, 50. 80, 75, 60, 40, 30, 50. We have taken the ages. And we have taken the percentage of regular players. You need not write percentage everywhere. That's not required. Just take the numbers. Okay. Now, since we are using assumed mean, you can take any number out of this as assumed mean. Any number. You will still get the same answer. Don't take any number means don't take some number in between. Here you have continuous numbers, so there's no problem. So for the first x value, here I have considered 15 as the assumed mean. The first number I have taken it as assumed mean. And for y value, 40 is taken as assumed mean. And you can also take 80, 15, 30. You can take, you will still get the same answer. Try once. Okay. So finding dx, that is deviation, x minus a, okay, x minus a, that is nothing but x minus 15. So x minus 15, x is 15, 15 minus 15 is 0, 16 minus 15 is 1, 2, 3, 4, 5. Like this, we have got the value. Now the total of this value is 15. The total of deviation of x is 15. Similarly, y minus a, assumed mean is 40. So do the calculation and the total of this will be 60. Now after this, square the deviations. Don't square x and y, square the deviations. So square these values first and then square. Okay, so there's a doubt which Arvina is asking, saying for x and y should we take different assumed mean? Obviously, my dear, you cannot take the same number. You cannot take 15 for y also. Okay, so take a different assumed mean for each of the data. I mean, for x you can select you can select the number from x values, y you can select the number from y values. That is all it means. Okay, I hope that I cleared the doubt for others also, if at all you had one. So square of dx and dy. Square dx, you get dx square. Square dy, you get dy square. Now after that, multiply these two columns. Multiply them. 0 into 40, 1 into 35, 2 into 20, 3 into 0, 4 into minus 10, 5 into 25. If you multiply these two columns, you're going to get dx into dy. Okay. After that, we have got all the important totals that is required to solve the problem. That is sigma dx is equal to 15, sigma dy is equal to 60, sigma dx square, that is okay. Dx, x will come down here and then square. And sigma dy square, sigma dx into dy. So we have got all the 5 values. Now we will go and do the calculation based on the formula. Okay. Now here in the formula, n into sigma dx into dy minus sigma dx into dy, sigma dy, whole divided by square root of n into sigma dx square minus sigma dx the whole square root of n into sigma dy square and sigma dy the whole square. So this is what is the formula. Now substitute all the values. N, that is the number of data, is equal to 6. So 6 into minus 90 minus 15 into 60 whole divided by square root of 6 into 55 minus 15 square into square root of 6 into 3950 into 60 square. And then if you simplify them, now you will get minus 0.9912. Okay, minus 0.9912. Now, say me, is this a positive correlation or a negative correlation? Quickly. Is minus 0.9912 positive or negative correlation? I want everybody to answer. Quickly type in the chat box. Negative correlation? Everybody is clear now? So minus value, it is negative correlation. Now, let us draw the timeline. In timeline, we have +1, we have 0, and we have -1. Since it is a negative correlation, we will write the benchmarks only here. Or you can write it everywhere, no problem. Plus 0.25 plus 0.75. Here minus 0.75 and minus 0.25 and minus 0.75. Now 0.9912 is very near to 1. Somewhere here you can assume minus 0.9912. Now I told you from 0.75 to minus 0.75 to 1, which degree will it come? Is it high, moderate or low? Which degree will it come? From minus 0.75 to minus 1. It is minus. I want more answers. I want everybody to answer. Be participative. Any more answers coming? High degree, correct? So you can simply write it as high degree negative correlation. It is negative value, so a negative correlation, and it is in the high degree. Here they have given very high degree. Why they have given is, it is very, very close to 1, right? This value is very, very close to -1. So that is why they have given it as very high degree negative value. That's all. And do not forget to write the factors. Between what and what are you finding the correlation? Between x and y. Okay. If the x and y has a name, write that name. Here, the correlation was calculated between age and playing habits of students or regular players. Or if there is no name given, just write it is between x and y variables. Understood? Any doubts in this problem? Everybody understood the conclusion part? Okay, great. Now let us go to the next problem. Now this problem does not have, x and y given. They have not given you all x and y here. They have given you few data which will help us to solve the correlation coefficient. Okay, this will help us to solve the correlation coefficient. Okay, so I think we'll have to just go back to the starting slides where we had, this is the basic formula of correlation coefficient. Okay, so that was assumed mean data which we saw. We solved correlation coefficient in two formats. One is actual mean, one is assumed mean, right? So this is the basic formula where you'll be able to solve the problem. So let us see this question. From the data given, okay, from the data given, we in the table, okay, I cannot see the question completely. From the data given, we are asked to find the correlation coefficient between series X and series Y. Okay, so you have two factors again, series X and series Y. Fine. Now let us see what all is given to us. Number of observations. This is nothing but n. What is the data that we have? Number of observations. For series X, there are 15 observations. For series Y, there are 15 observations. Okay. Next, arithmetic mean. X bar. Actual mean is given to us. This is X bar for X series, Y bar for Y series. Okay. So arithmetic mean. Then standard deviation. So standard deviation of X is given. Standard deviation of Y is also given. Then sum of squares of deviations. This is interesting to understand. Sum of squares of deviations. This is n, this is X bar, that is actual mean. And then we have standard deviation. Sum of squares of deviation from mean. We will read it ulta. Deviation from mean means X minus X bar. Correct? Deviations from mean is X minus X bar. So what are they saying? X minus X bar has another notation which is nothing but small x. This is deviation from mean. If you total all these deviations, you get it as summation x. Now, sum of squares of deviation. Deviation is small x. Sum of that is sigma square. So, sigma x square is given to us, that is 135. Similarly, sigma y square, sum of squares of deviations from mean, is 138. And okay, so that was 1. Did you all understand this part? Sum of squares of deviation from mean. You have to read it a little in a reverse order. Deviation from mean and then sum of squares of the deviation. Understood?